As I said before, Houdini supports many methods and algorithms to compute global illumination. The first one we will be looking at will be by using the VEX Global Illumination Shader. So this technique uses the irradiance computation. The irradiance computation will sample the hemisphere over the point being shaded, and this way it can compute the incoming ambient light. This method is usually expensive, but we can speed it up using the irradiance caching, which we will be talking about later. For now, let me just go back to my object context, and here I will hit Tab, and under Render I'll create a light template. It's not showing on your screen, so let me just take this a little bit up. And here under Render, I will create this light template. This method is fairly simple. All what's left to do is for you to go to this shop context, and here I will hit Tab, and next I will type VEX Global, and you can see it popped up here, VEX Global Illumination. I'll create a VEX Global Illumination node. Under its parameters, I will just change the irradiance style from ambient occlusion to full irradiance. I will go back to my object context, and I will provide this light template node I had just created with this shader I created in my shop context. So I will go to its Render tab, and under Shaders, I will just click on this button here, and I'll make it point to my VEX Global Illumination light shader. I will hit Accept, and then I will do a render of my scene. I will wait for it just 2 seconds. It's rendering, and you can directly begin to see the effect of the irradiance going on. You already know that my 2 spheres have white materials assigned to them, and even though you can begin to see this pinkish color appearing on my sphere, I will stop the render here and I will be back when it's done. And here's my render. So now you can see the effect of the irradiance is very pronounced, especially, for example, if you look on the left side of my left sphere, you can see this red color going on, and on the right side of my right sphere, you can see this green color going on, and that's what we call color bleeding. This is due to the irradiance calculation, or to this global illumination algorithms, which is calculating the lighting inside my scene. And let me just show you something so you can see it more clearly. I'll just delete this light template I had just created to create this global illumination effect. I'll just delete it, and I'll hit render again, and now you can see my scene without this global illumination going on. I'll just compare the 2 images. You can see my first image, which has the global illumination calculation, and you can see the second one, which has those 2 spheres which are now missing the red color, the green color, which are darker. You cannot see their bottom faces anymore, while in my first image you can see that their bottom faces are lit, while here they are pitch black. So you can directly see that by using this VEX Global Illumination Light Shader, we've got that global illumination effect very quickly, and it's very simple to set up. So here's the scene with global illumination, and here's the scene without global illumination. And the effect is huge. Just by creating a simple light shader, a light template, and linking them together, look to the effect you gave to your scene. Let me just hit Ctrl Z to get the slide back, and I will go to its parameters. And here you can see that there are many parameters you can tweak, like this global tint. You can just tint the overall color of your global illumination. You can make the tint red, blue, whatever you want. And this irradiance style let you choose between different styles of calculating irradiance. One of the other irradiance styles that may be also very important is this ambient occlusion irradiance style. This ambient occlusion will let you get irradiance computation in your scene, but without the color bleeding, so it can be very useful to calculate an ambient occlusion path. Next thing you can see here is the sampling quality, where you can tweak the quality of your irradiance calculation, and it's obvious that the more the samples, the more the render time. Here you can turn on adaptive sampling, so Mantra can decide what are the areas of your image that needs more sampling, and this way you can decrease your render times by letting Mantra decide that the areas that don't need a lot of sampling will have less sampling. You can see other parameters such as this maximum intersection distance. In fact, this maximum intersection distance will tell Mantra that every ray that traveled more than this distance and didn't intersect with anything just will return the background color. And you can see other parameters such as the sampling angle. Here you can specify an environment map. We will get back into that later. I will show you an example of that. And this background color, which, as I told you, if the ray traveled more than this maximum intersection distance and didn't intersect with anything, it will return this background color here. Another technique to calculate the global illumination is the photon mapping. And here in this VEX Global Illumination Light Shader, you can see a photon maps tab, which we will get into later, and I'll show you an example of that also. For now, let me just go back to my object context. I'll just delete my light template, and now we will move on to the second technique, which will be by using the physically based rendering engine.